everyone. It's 1:40, so welcome to this week's ITS seminar. I'm hosting today for reasons I'll explain in a minute, but I want to do a few just kind of announcement kind of things first. Just want to note that next Friday we're doing a different kind of seminar. Carrie Watkins is stepping in for a speaker who had to cancel, and it's going to be more of an open discussion about using Davis and the UC Davis campus as a research lab. So she's really hoping you all are going to be actively participating in that next week. The second thing I wanted to remind you all about, and we sent it out an email about this today, is a student town hall at ITS on Friday, November 17th. I encourage you all to participate. This is a chance for you to share your thoughts about what's good about being affiliated with ITS, what's been challenging about being affiliated with ITS, ideas you have for things that ITS could be doing with respect to whatever. This is not a meeting about TTP. This is a meeting about being a student affiliated with ITS. Whether you're a graduate student researcher housed out here or participating in seminars or whatever else you might be doing. So please participate if you can in that. This is your opportunity. And then the third thing I wanted to remind you is that ITS has a new DEI statement, diversity, equity, inclusion. And please take a look at that. We think about DEI from the standpoint of the work that we do, because diversity, equity, and inclusion has been an issue in the transportation world forever. So our work is trying to help overcome that. But we also care about DEI within ITS as an institution. And I just want to, I think we like to think that we're open and welcoming to everybody who's here, regardless of anything, that we take you as you are. But I do want to say, if you're feeling like that doesn't feel true to you, please come talk to me or find somebody else you feel like you can talk about that to here at ITS. Okay. So I'm very pleased to introduce today's guest speaker, Fengxiang Qiao. Have I handled that?
Correct.
Okay, close. Hopefully that's close. Who's a professor and co-director of the Innovative Transportation Research Institute at Texas Southern University in Houston, Texas. I'm proud to say that TSU is a new partner in the National Center for Sustainable Transportation. As I explained a couple weeks ago, we just got the new grant for that. That's going to go for 5 years. And TSU joined us in that partnership. So we'll be working with them for a while. And what we're going to hear about today is their work on air quality and emissions modeling, well, emissions modeling in particular. Which is something we haven't been doing a whole lot of here at UC Davis in recent years, although we used to do more of that. But our other partners at UC Riverside and Georgia Tech, the Fengxiang's group has been working with them over the years. So we're really looking forward to sort of expanding our emissions modeling capability. And the NCST has mechanisms to have you all connect to our colleagues at these other institutions. So if this is something you're interested in and you're not finding enough of it here, again, come see me and we can connect you into our partners and take advantage of the work that they're doing. And then we're also hoping to collaborate with TSU on some other things. Like yesterday, we're talking about the fact that they're getting a bicycle simulator, which means like a virtual reality simulator, which would give us the capability of doing some interesting experiments about the effect of different kinds of environments and environmental conditions on bicycling behavior and stress things like that. So we're going to do some brainstorming about how we might connect. So again, just a great opportunity for you all now that we have this partnership with TSU. So it's time for me to turn it over to Fengxiang, and we're looking forward to hearing about your emissions work.
Thank you, Susan, for your wonderful introduction. It's very great to be proud as a new member of the NTST. Yesterday and the day before yesterday, we had a very wonderful executive meeting. So I see a lot of collaboration opportunities with almost all universities in the group. Very wonderful, especially for this event. And I appreciate that Susan had already introduced several professors in the ITS group for the possible connections. And we will do that, including the bicycle, vehicle climate simulators, emission modeling testing, and we will learn from you about the policy every part. But also, I'm very glad to see Michael Zhang, who is my old friend. I know Michael Zhang for more than 20 years. But this is the first time I meet Davis with the office here. Very wonderful. And also, I appreciate so many students come here. I know each of you have prepared 3 questions. I may not have enough time to answer all your questions, but I'll try my best to introduce what we are doing in terms of the emission part. I will not touch the simulator part today. So today I give the topic of measuring modeling impact of vehicle exhaust emission. We will focus on the vehicle exhaust emission. That means emissions coming from the gasoline vehicles, diesel and regular gas vehicles. And TSU is, as Susan introduced it.
Could you speak a little louder, please?
A little louder?
There are many seats up here. If you can't hear in the back, please come forward.
I'm speaking for everyone else.
Okay,
Okay.
but anybody, we've got lots of seats up here. Come forward.
Okay, TSU is the HBCU, historically Black college and universities. And so currently the government have special support to the Black people. So that's why they have these types of universities. They have special funding support, and they have special educations to those people. I think that's a part of DEI, diversity inclusive efforts. We are the second largest in the country. And for the emission testing, using the PAMS, which is a portable emission measurement system, we have used the equipment for 20 years, exactly 20 years. At the end of 2003, Dr. Liu and me flew to New York, to Buffalo, to carry the equipment back home to Houston. So starting from there, we tested the vehicle emissions. And at TSU, we have 2 PhD programs, especially the first one, which is called environmental toxicology. So I'm affiliated with that program. So my PhD students should work there. They should have a chemistry and biology background. So we work on the ways to reduce the vehicle emissions so that we can benefit the environment, to reduce the toxical impacts to the environment and to the human health. And also we have urban planning and environmental policy program, which is in a different college, in the public affairs college. And also the second one that I highlighted is a Master of Transportation Planning and Management. This is my home program, home department. So most of my master students are in this program, but we do have other relevant master degrees and undergraduate degrees. And also we do some education efforts. We also educate the K-12 people in high school. For kindergarten we set up a trampoline environmental club in kindergarten, not kindergarten, sorry, elementary school. We set up a group to let them know when they are very young about the environmental impact. Okay. Yes, and at TSU, our research related to environmental studies are mainly on the Innovative Transport Research Institute. Dr. Leo is the director, I'm the co-director. So it was expanded from our urban traffic and air quality lab. We have been running this one since year 2000. Actually, this is the year where I came to TSU. So actually, the first day I started there, we already started this lab. We started this research. And our goals are to develop, evaluate, optimize, and recommend comprehensive strategies for traffic congestion mitigation, mobile source emission reduction, fuel consumption saving, and transport planning, ITS development, this kind of stuff. We have a mission to conduct innovative research development for optimal solutions to our transportation system. We have done a lot of efforts under this research institute. We do emission testing, modeling, we do air quality impact studies, and also if we expand that to the impact on the public health. Even though we are not health people, I'm learning also, but we did some on like heart rate variability or stress, this kind of studies. And in addition, we also do modeling, simulation, planning, ITS, and driving behavior studies, which are mainly conducted in our driving simulator lab. We have done a lot of tests of the driving simulators. If you're interested, we can talk later on or talk to your relevant faculty and students on the driving simulator test. And also, we do some kind of education and training on transfers. We have funding sources from federal and state levels. But most of our supports were from TechStop, actually. It's a department. We do have from many other sources like UTCs, like ACST. So again, we are proud of being a new member of ACST, and we appreciate Susan and many people in Davis lead this effort. And in our lab, we have some very special equipment. The leftmost is a mobile lab. This is relatively old. And the second one from the left is a driving simulator. We are renewing it. On the bottom, the second column is our oldest version of the simulator. On the top, that is the one we are having with 7 screens, but smaller. Last year, our president gave us a special fund to purchase a new simulator. We are purchasing right now. It will be installed this semester. That one has 3 big screens, right? Big screens. And it is associated with a bicycle simulator. And also we are buying the pedestrian simulator with a VR capability. So all of them will be connected in a screen. So you can see the bicycles when you are driving in the driving simulator, and the bicycles is controlled by different people in your lab. And also this simulator can be worked together with simulators in other labs, in other universities, other locations all over the world. So we are identifying the opportunities to work together. So I don't know the simulator type you have in Davis. When I have the chance.
Do we have a simulator?
Not in the vehicle or transportation.
Or not in vehicle transportation, maybe in other areas. I know in our they have many in even in College of Medical Science or College of Computer Science, they have so for different purposes. Not, so the simulators cannot be, can be used in not only in transportation. But the third one is the pens. On the map, on the picture, you see the pens. That is the one we are having now. We have it for exactly 20 years, but now we are purchasing a new one to replace it. The new one will be smaller with more capabilities. As in Riverside, they have similar ones. We have used that. I've conducted a lot of research. Actually, for our formal seminar today, we already communicated with other students here. Some of you also had kinds of experiences, or you have read some papers about hands testing environment. So we will talk more and more. The right hand side is we call the mobile or mini TranStar lab. In Houston, we have a TranStar, which is a transportation management center with more than 1,000 camera surveillance system. But that one is transmitted to our lab. We have the full control of all the cameras in Houston area. We can record the data. Because TranStar, they don't record data. They just let the video go. So, but we also don't record any kind, but once there is a need, if we want to focus on an area for a particular research purpose, we will download, we will analyze. We don't use the manual count, we will have software to count for us. For the traffic volume, speed, vehicle length, density, it can be recorded out. And in the past, we have done a lot of research. This is one of the sample studies that I have done. I developed an RFID-based driver smart assistance system. Actually, this is based on my personal interest. My undergraduate was on medical control engineering. So I like this kind of things. We use the RFID to provide a warning message to the drivers, and we see the reactions, whether they will enhance the safety. It's for safety purpose. I tested in stop sign intersections where the stop sign is blocked by the trees or big vehicles. So this kind of system can provide a warning to the driver. And also on signal lights where you have sunlight, sunshine, sun glares for sun glare, and also walk zones. But I did road test for a short time. Then I realized it's not safe. So I merged, bring everything to the driving simulator lab. I did all the tests in a simulator, actually more. In simulator, you can assume a lot of things. For example, for work zone, or for the sun glare, for the stop signs which is blocked, you can add many skills. For example, pedestrian crossing or a pet, a dog crossing. But you cannot arbitrarily add those kind of scenarios on road field test. We did a lot of this kind of tests. So definitely later on I will focus on the emission testing, especially the pavement emission, pavement roughness impacts on the emissions, and also for the health. For the health impacts, we used the heart rate detectors, and also we tested the sound, in-vehicle sound, to see the noise impact on drivers, not on the ambient part. We also did on the ambient to see the trees or the buildings or even some walls, whether they can block the noise impact from the transportation system. But we focused on the in-vehicle noises. We had some kinds of good findings. We also related this one with different types of pavement, like asphalt or concrete. The in-vehicle noise is totally different. we published this one in journal AWMA, Air Waste Management System. Several days, within a week when it is published, then I got a call from a radio station in University of Houston. they brought me to their office, to the studio, to interview me on air about that kind of research. We did a test in 59 freeway in Houston. And also, supported by a textile project, we try to do kind of equity analysis. So we studied the in vitro performance of roadside safety devices to see whether we have the good placement or maintenance of the safety devices in the urban area and the suburban area. But definitely we found that at least for textile in Texas, it's not sufficient. The efforts are not sufficient for the rural areas in terms of to protect people's safety using the safety devices on the roadside by different types. We used a machine learning model to see the difference. And then I focus on 3 topics today. One is in general, the emission impacts on air quality and health. And then the second one is from one of my previous studies. It's a pavement impacts on the vehicle emissions. The last one is also from a study we did in my group, the mobile source urban air pollution forecasting with a lot of factors considered. We use a machine learning model. The first is the emission impacts on the air quality. The vehicles are generating emissions, especially the petroleum fueled vehicles. The emissions will impact the air quality and also eventually impact our health, the human health. And so when we are emphasizing the mobility of a transportation system, you should be aware about the cost on the environment, the cost of money, cost on the social side, even the ecological system. So you will consider the internal cost, external cost, environmental impacts, everything. So I don't want to go to the details. And the environmental costs include the internal cost, complaints cost, contingent cost, or image relationship to the subjective perceptions of the stakeholders and some external costs. So we will consider a lot of things. For the environmental system, we will consider the entire biosphere system of our Earth. We will consider the hydrosphere, lithosphere, ecosphere, atmosphere, everything we need to consider. This slide is very small, but it lists the environmental impacts of the transporting system on each this kind of spheres where I listed in the previous slide. There are many. I don't want to go into details. And also this one, I think most of students may be familiar with that. The transportation will have the impact on the environmental dimensions. So the land use and the economic growth will be the causes that will will stimulate the activities, including the transporting activities. This is a broader concept of transporting activities, including the infrastructure, everything. And then the output will be the exposure for human beings to be in that kind of environment, and also emissions, and they will change our habit finally. And the end result will impact our social system and ecological system. And it will impact our health, the entire environment, and many other factors. Transporting activities, how transporting activities will affect the environment. We have the infrastructure, we have the vehicle manufacturing. For example, we have electric vehicle or diesel vehicle or gasoline vehicle. The vehicle, this kind of vehicle manufacture will also have some impact on the environment. And the operation of vehicles. Then, for example, eco-driving, probably sound you heard, right? The eco-driving means when you are driving, you will try to eliminate your impacts on the not ecologically, but for the entire ecological system. So the eco is different from the eco that you can see on some of the vehicles dashboard. So when, for example, when you are approaching an intersection, if we can reduce the speed and to some extent, so you will not meet the red light, you can safely pass the intersection with a reduced speed. So that means you don't have a sharp deceleration and acceleration. The acceleration and deceleration will bring a large amount of vehicle emissions. So in that case, we will have the reduced emission, reduce the impact to the ecosystem. So the vehicle operation will impact the environment. And the vehicle maintenance, good maintained vehicle will bring less emissions. And vehicle recycling disposal, that's the final step. So that will impact all modes of transportation: maritime, rail transportation, roadway transportation, air transportation. And also for different types of traffic, passenger vehicle and freight vehicles. And also transportation system. I know some of you are working on transportation planning, right? Transportation or even urban planning, the network design, the network, starting from the network side, the centralized network and the diffused network, they will bring different types of emissions. For the diffused network, the emissions can be spread out easily. Most of the emissions, not all, but carbon dioxide they cannot. But for most of the emissions can. But the total energy cost will be high because you need to drive longer. Like in Houston. In Houston is so spread out. So it's very special. So people need to drive at least a half hour. Most of the people drive 1.5 hours when on the traffic, go back home.
1 way?
Yeah, 1 way, yeah. 1 way. So entire day you need to drive close to 3 hours. So you will consume a lot of energy on road. But since the network is so spread out, the emissions can be disappeared very quickly. So the impact to the health will be less than the condensed, centralized network, like to the left-hand side. But the total energy cost will be high. Actually, in one of our summer schools for the high school students, I designed a coursework for the students. Let the student to calculate the total emissions generated by these two different types of network. Then I give them some assumptions. Use the Houston network. Just assuming that you are 200 years ago, you are the city council member. You are trying to redesign a network for Houston. So there are 2 plans. So the total emissions will be different. Energy consumption is different. And in terms of different chemicals from the vehicles, their impacts in terms of the areas is different. Like for need, noise, and PM, particular matters, normally they impact locally. So if the urban network is diffused, this impact will be small. And also for NOx, their impact will be regional. And they can, like in Houston, they impact the ozone. So Houston, our ozone is non-attenuated. Houston is classified as non-attenuated area or near the non-attenuated area. We will have the federal funding cut because of that. But for carbon dioxide, the impact will be global. The carbon dioxide here can impact China or Africa everywhere because it goes globally. For the pollutions, we have air pollution, we have water pollution. I also did a little bit study on the water pollutions. In Houston, we have the ship channel. I studied the chemical density along the ship channel. The ship channel goes from Houston downtown, then to the Galveston Bay, and then to the Gulf of Mexico. Then we see the density of the chemicals. They are different. And also soil pollution. Transportation have some kinds of impact, but not too many. For some gas stations, they have some leaks that impact the soil, example. And also we have other types of pollutions. The air pollution will have the cost, will bring the cost on the economic side, social side, and environmental side. And also, they will impact the health. The different chemicals, they have different impact to the health. So for those that impact the health, most seriously, we call them bacterial air pollutants, which are defined by EPA, Environmental Protection Agency. So that's why we have a term called bacterial air pollutants. Most likely the PM, particulate matters. In some countries, Middle East, African, China, their PM are very high. But in here, in the United States, our PMs are very small, especially in Houston. It's not an issue. But for the second one, the ground level ozone, we have a big issue in Houston and Dallas. For the entire Texas, we have two areas, Dallas and Houston. Their names are always listed as non-attenuated or nearly non-attenuated areas by the EPA. And the carbon monoxide, sulfur dioxide, nitrogen dioxide, and neon. So these are bacterial pollutants. Actually, in the past years, decades, we have a lot of efforts of many parts, car manufacturing, and some efforts from scientists, chemistry, and environmental scientists. They have done a lot of efforts. So the emissions, like NOx, are reducing actually, and the ozone concentration are reducing, but still not enough. Still, in some areas, this is the data is for the entire Texas, but for Houston, for Dallas, we still have some issues. So there is the ozone watch. NASA has the ozone watch. If you're interested, you can go to this link. So, it will give you the ozone not only in the United States, but in the whole global, everywhere in the world.
Doctor, I had a quick question for you. So you brought up how Houston itself has low particulate matter, but is has high ozone and nitrous oxide levels. And I think you already addressed this. Is that because you have this high ozone, low particulate matter? Is that because the area of Houston is so spread out that the particulate matter is
at least one of the
one of the reasons?
And also we have a large population of vehicles. The traffic is heavy. Actually, this slide and next slide tells you that transportation contributed to 27% in terms of the greenhouse gas emission for 2020. But for other emissions, we also have similar portion. So transportation is one reason why we have that kind of ozone. But another reason is that the chemical plants. Houston is a capital of chemical engineering. There are many chemical plants there. They also produce a lot of emissions.
Is it nitrous oxide
Yeah.
that these plants are emitting?
Yes.
Okay.
Many these kind of things. They are called stationary salts, but the vehicles are called mobile salts because we are moving. But the chemical plants, they are fixed. So from transportation side, from transportation engineering studies, we focus on vehicle emissions, but we don't touch the chemical plants part.
So I'm just assuming that even if the city of Houston eliminated the mobile
We
sources,
still have a lot.
there's still the chemical plants,
Still
which
have a
means
lot
the
of chemical-
the ozone is still going to be just as high, essentially.
Yeah, but I don't know whether it will be higher than the standard or not. Currently, they have the standard, very strict standard. The standard is more strict in terms of the ozone. If you use all the standard, Houston is okay.
On that point, do you know how it compares the VOCs or criteria pollutants and emissions from road transportation that you studied to maybe the refineries and petrochemical ones? And
We have not compared that one. We have not touched that part. But normally, like EPA and USDOT, they monitor to see which portion, which sector contribute how much.
or
Which one
maybe
is
like
more.
if we were to juxtapose like this one to Houston or to Texas, is transportation about the same, 27 also?
In Houston is around that, yeah, around 20% or 30%, around that. But I didn't do that study. I read from some kind of sources. It's around. And on next slide, talk about 2022. The transportation portion is even higher, it's 37. I just got this one this morning from EIA, from somewhere, the government. It's even higher. And even within transportation, we still have 96% coming from the petrol. Even though we talk about EV electric vehicles, still a lot from there. So our research on the gas emissions or diesel emissions, I think we still have some efforts to do because a large portion is still there. So for my first topic, I just briefly introduce those data and concepts. Most of them are not by individual research, just from the government publications. So just like introduction, I use that one in my course. I have a summer course called Quantitative Analysis of Air Quality. Normally in that course, I use that one as an introduction to bring people's attention. Then I go to the second one, which is my research. I also communicated with several students before my formal seminar today. It's pavement condition impacts on vehicle emissions. So we borrowed what is used in modes. Modes, they separate the vehicle operation status into different operating mode ID. Later on, I'll show the table. Not too many.
Can you explain moves
Oh,
for the students? I'm not sure everybody.
yes, MODES is a model developed by EPA, Environmental Protection Agency. Okay, let me go to, sorry, I don't have the internet account. It's called MODES. Actually, it's abbreviation from like a mobile source emission estimation simulator, something like that. So currently they have a new version called 4.0. I talked to President yesterday also. Before MOOS, EPA used mobile, but except for California. California has their own model. So maybe this is not applicable for you. But I'm not talking about MOOS today. I just followed the concept from MOOS. MOOS, they used the operating mode ID beam. But for those who they know you will find a job in other states, probably you still need to know MOOS if you stick on the environmental side, or even on the planning side. Because in many government agencies, like TxDOT, their environment and planning, they are together in the same group. So we have to do both. So in the MOOS, they separate the operating mode of vehicles into different pins. They give different ID, 0, 0, 1, 0, 1, 0, 1, 0, 2. I will show you later on. Each of them represent different speed accelerating rate. And also they create a new term called VSP, vehicle specific power. Based on speed, accelerating rate, and VSP. So they have different combinations, they create a different operating mode. So under different mode of operating mode ID, I studied the pavement impacts on the emission factors inside that specific beam. Because why I do that? Because when I did that kind of research, I used the data from Texas, 1,000 miles testing. I found that if you do in general, I cannot see the impacts of the pavement conditions. The reason is that it's very obvious. Speed and acceleration rate contribute the most to the vehicle emissions. If you accelerate, you will generate a lot of emission. Right? If you drive at a steady speed, the emission will be low. So it's very obvious. So the impact on the pavement roughness will be merged with that. However, with the MOOS operating mode ID beam, since in each beam they have very similar speed and accelerating rate and VSP, so we can exclude the impact, or almost exclude the impact of speed accelerating rate. So we can see the impact of other factors like pavement type. So this was my idea. Vehicle emission generate a lot of air pollutants. Right? But traditionally, in order to reduce the vehicle emissions, people are trying a lot of technologies to improve the vehicle efficiency or fuel types, but they pay less attention on the roadway design and geometry design. Current standard roadway design and geometry design, like the Green Book, they have no mention about the vehicle emissions. Actually, I had a couple of students. Their thesis were on the testing of emissions under different geometric designs. We found that it's different. It's different. The geometric design will impact the emissions. So when you have the manual for the geometric design, roadway design, you will not only consider about the safety, right? The delay. You will also consider the air quality part. So this was our recommendation actually. And also the driving behavior. Driving behavior is complicated. The way you accelerate, decelerate, or whether you will, like eco driving, I used as an example, when you are approaching the intersection, you try to reduce your speed so that you can catch the green time. But if you don't have the vehicle to infrastructure communication, you don't know how to reduce the speed. Right? So this will be possible only when you have a connected vehicle in electric, especially connected vehicle. But autonomous vehicle will be better because the speed will be automatically controlled. However, by human drivers, even though it's not autonomous, it's still okay if we give you advice. So we tested these kind of situations in driving simulator, give people different advices, and we also tried different information from the voice message, and we tried a different gender, male and females. The results were very interesting.
Who creates more emissions?
Yeah, but you wanna share them?
Yeah, but not today. I didn't bring the PowerPoint here. For those law enforcement messages, males can give better results. Males, just like speed limit, or we have to stop. For this kind of situation, if the message is from male, people will follow. Will better to follow. But if for guidance, like you better to reduce the speed, you can change that here, but it's not necessary. But just kind of advisory information, make females is better.
It's more persuasive.
It's very important. Interesting. We got from the driving simulator test. We analyzed the data, not only from the questionnaire, but from the test data, because we can see by this kind of voice message where they stop. If they stop too close to the stop line, or even beyond the stop line, that means it's a bad situation. But if they can reduce the speed gradually, step earlier before the stop line, we see that that's a good compliance to the message.
So the voice are real voice or AI generated voice?
No, a real one. We did that one 4 or 5 years ago. At that time, sorry. You can say it's AI because we got the voice from Google search. We searched from online to get a kind of standard voice. I believe those voices are not from human beings. They're true. So, but you can do a lot of these kind of studies. Very interesting. And also pavement condition. So for this research, we'll focus on the pavement conditions. But definitely for other factors, you can have a lot of study choices, even for fuel types. So for our studies, we selected the carbon monoxide, carbon dioxide, hydrocarbon, NOx, fuel consumption. FC is fuel consumption, and particular matters. The reason we selected these, one is that these are important material factors, most of them. And the second one is that our pens can give us this kind of data. So we can better utilize the test result. And then emission factor is a representative value that attempts to relate the quantity of pollutants released to the atmosphere. It is in the unit of ton per gallon, so per mile. So the unit is like the weight divided by mileage. So it's called emission factor. We also have.
Does the pens measure particulate matter?
Yeah,
That's what you said?
those on left hand side, those are from pens, but we also use that one for this study.
And do you know what size of particles is this measuring?
Although we don't know which type, we just know the size. 2.5 or 10.
Okay.
But we don't know what exactly the particles. But for those particular matters, they have that impact to human system, especially 2.5, because 2.5 cannot be filtered by the human naturally. It comes to your body. it will cause non-cancerous MRT. So in terms of the emission units, we have emission factor and also we have emission rate. Emission rate is the gram or milligram per second. Sometimes we use per second. The reason is that if used per mile, gram per mile or milligram per mile, when the vehicles are idling at the intersections, waiting for the traffic light, waiting for the rate, you don't have mileage. So you will divide by 0. It will make no sense. So we use emission rate for idling case. But for the idling, it's very interesting. What is called idling? For moves, it says as long as the vehicle speed is 1 mile per hour, within 1 mile per hour, it's called idling. But in the earlier version, before moves, it's called mobile. It is used in 49 states except for California. They use 2.5 miles per hour. Then I checked many literature from EPA. They don't have any place to indicate why they choose 2.5, why now they say 1 mile per hour. So then I used my tested data from AMS. I used digital signal processing method, used my filter to filter a lot of cases when we have the idling. Then I found for my tested data, I cannot say for all vehicles. For my tested data, the best classification between idling, no idling is 1.6 miles per hour.
The 1.5 is close to that.
Yeah, close to, it's actually between 1 and 2.5. It's in the middle, because I see the chart like this. So I find a transaction point, cutoff point, to find it's 1.6 mile per hour. There are not of details to look at. For the roughness, I know many of you, since most of you are with civil engineering background, so you know what II is, International Roughness Index. And they have the categories A, B, C, D. This is from, actually this is not from the manual, it's a little bit different from the manual. I created this table with my one of the PhD students because we, based on our test data, we recalibrated the IRI category based on their emissions, the manual emissions. I used the clustering method to find the clusters, each category, and find a boundary. Then we get this. It's very close to the engineering standard that is widely used. But for my own research, since this is in my own research, I use this one. But if you are using for Caltrain, for TechStop, for DOT, you better use their standard, don't use mine. But this is not official. So the smoothest one will be category A, the rougher one will be category D. There are lots of emission models. We have macroscopic, microscopic. In the middle, we also have mesoscopic models. Most, as I mentioned, it's called Model Vehicle Emission Simulator by EPA, Environmental Protection Agency. Most generally, it is a macroscopic model, but it has a project level. They have national level, county level, and project level. If you go to the project level, it's already can be kind of microscopic analysis. You can analyze the emission for a particular project. The project could be on one roadway segment or one arterial road. It's already microscopic. But in most cases, people use it for SIP, State Implementation Plan, or for conformity studies. In that case, you will do the microscope, like for the county, or even for several counties. Like in Houston, we have HGAC, Houston Gangster Area Council, which is the NPO, Metropolitan Planning Organization. They oversees 13 counties around Houston. Houston belongs to Harris County, is already big, but they oversee the 13 counties. So normally they do for 13 counties emissions, or at least they do 8 counties around Houston. Those are most close to Houston. It depends. So in that case, you will use the county level. And actually, I'm interested in what Dr. Gessner talked about the most metrics, because he said he can save a lot of running time more efficiently. So I try to learn from him about his work. So the major inputs to the moves will be a lot, like the scales, like a national or county or a certain road. Also, you need to tell the model about time span or geographic boundary, climate, vehicle specifications, roadway type, or pollutants in the process of emission. Then the EPA has a different model they call long road, that is specially for long road equipment. The model itself is called long road. It comes from the abbreviation from long term, which is called long road. So most especially for the moving vehicles. But if you are touching on some equipments like long mower or for local road, there are a lot of equipment. You may use a long road. So if you are going to analyze the emissions in a port, for example, probably you will use both moves and long road. There are not a lot of long road equipment there. But we are trying to see the pavement type IRI impacts on the emission. In the moves, they don't have. They don't have the consideration about the pavement type. So on the right hand side, this is the operating mode ID that moves is using. They classified the vehicle operating mode into different categories from 0 to 40. We cannot say it's 40 because those are just codes. They are not numbers. They are characters actually. 0 means braking, acceleration, hard acceleration actually. Just hard deceleration. 1 means idling. Idling, they define like the speed is 1 mile per hour, forward or backward. And starting from 11 until 16, those are for lower speed. The speed range is less than 25 miles per hour, but greater than 1. So this is lower speed. They also have moderate speed between 25 and 50 miles per hour. So those cases, they start with 2. And for the high speed, which is speed is higher than 50%, their code is most likely starting from 33 to 40. But even for the low speed, for example, they also have different categories because they consider the speed, accelerating rate, and the VSP, vehicle specific power. I think later on one slide I have the equation to show a simplest version of VSP. VSP considered speed and accelerating rate. It's a complicated function of speed and accelerating rate. They have 21 modes to represent different situations for cruise, acceleration, and 2 modes for the coasting, VSP less than 0, and 1 mode for idling. So I borrowed this idea, I borrowed this table, I classify the speed acceleration different based on this mode and to see the impact of roughness. So this is idling, where I measured like 1.6. The roughness, there are other people they have done kinds of roughness emission studies, but one is that they may focus on carbon dioxide only, and also they may just have a general trend to say that if the roadway is too rough, the emission is high. We don't have very detailed study. So we are trying to develop a model which is microscopic. Microscopic means we consider instant speed and acceleration rate. We call it VSP-based vehicle specific power. Vehicle specific power considers speed and acceleration rate. And we use the emission data, onboard emission data from the PAMs to develop VS-based model. So this is our the modeling process. So we borrow the modes. I don't want to go to the each specific block, but you will notice that we have the consideration about the pavement roughness join that. So we see the research gaps. So this is our research framework. We have 3 blocks. One is to connect the data, connect the speed, acceleration rate data, connect the relevant road roughness data. The roughness is from an app, a mobile app from a cell phone. And then activity data, we process the data to align the emission data with the speed and frame rate data, because they are from different devices. Their sampling intervals are different. And also develop the model. Basically, we have 2 types of models. One is polynomial model. Another one is kinds of machine learning model. So I will talk later on. So for data connection, this is the PAMs, the equipment. And then this is the vehicle we use to test. And then the PAMs connect to the tailpipe. So the emission is coming to the equipment. This is the cell phone app. We got this from a company in Europe. Actually, they sell this app. It's very expensive, but they gave us for free. The reason is that they don't have the data in North America. So they want us to share with them the data. So they
This
don't.
is the roughness data.
The roughness data, yeah. They don't have roughness data in North America. So that's why they require us to upload the data, and they pre-process the data and then send us the process data. We cannot get the data in.
What type of data and what?
Roughness, just the roadway roughness. Yeah. Actually, we have the roughness data from Textile, from Textile Department of Transportation, but their data was also processed. They only gave us data every 2 miles or every 1 mile. We cannot get the original data. Maybe it's too complicated, so we just use this one for our purpose. And this app was calibrated. Their data was calibrated with the real one, where we really will measure that. So we just trust them. This is the information for our vehicle and the engine specifications. The app is called roadway. They ask us to mention your name in our applications. Because at TRV, I went their booths. They told me it's very expensive. Maybe several years ago, they said 30,000 a year to subscribe.
I guess
But finally,
their main customers are the DOTs or
DOTs,
cities.
yes. It will save their time. They just drive, they get the data. But I didn't talk to them directly. Our partner, UT El Paso, because they are pavement person. They talk to them. They give us a good deal.
So we only have 2 total.
Oh, okay. So probably let me try to finish this portion. Yeah. Okay. We tested a total 1,000 miles data in throughout Texas, but Houston is the longest, 700 something San Antonio, and we went to El Paso. El Paso is special. We tested different areas, and we process the data in different steps. On step 4, you will see the equation for VSP, vehicle specific power. But this is a simplified version of VSP. If you do Wikipedia, you will see the complicated version of VSP. This is for night duty vehicle when you are driving on with no stove. They have some conditions, but in Houston at least we are in a flat area, so we use the night duty vehicle. So we use this equation, the red one. And then I don't go through the very details. First, we used polynomial model, polynomial regression. We started from the very simplest one. Polynomial one, let me show you the result. This is result, but this cannot tell the details. Okay, before we go to the result, actually this is from the data. We didn't do any modeling. I just aggregated data by different areas. And then on the x-axis, you see A, B, C, D, the roughness. Then you will see this one, carbon dioxide, this one carbon monoxide, hydrocarbon, NOx, fuel consumption. For all emission and fuel consumption, we have this trend. The leftmost of each chart is the smallest node. Right hand side D, that is the roughest node. So we'll see this trend. This is actually, if you know more about the trampoline emission study, there is a similar curve. If the x-axis is speed, we always see this kind of trend, right? In the middle, like 55 to 70, that is the lowest. That's the lowest. But it's very interesting that for the roughness, we also have this kind of chart. This we didn't do any modeling, just from the roadway application. But the data size, sample size is different. For D, we have very few data. And for B and C, we have to get most of the data. For A also, we have a lot of data. So I just show the model. Model in general looks not very good by using the polynomial. So you will see for operating model ID, for each rule represent each different operating model ID. And then this is emission factor for that kind of operating model ID. R squared. This chart shows R squared, so we'll see the R squared. R squares are not high. And then we look for different models like decision tree or other types. We use the IBM SPSS model to help us to select the model. Actually, I remember, this was conducted by one of my master students. She was from somewhere in Asia, not from China. But when she got the result, she cried. She said, how can I graduate? How can I produce a TRD paper like that? Then I say, how about you try modeler, SPSS, to look for better model, not polynomial model. The next day, she was very happy. She said, oh, I got very good data coming out. Finally, she picked up the random tree model. And
some of you are using things like this.
Yeah, I believe many people are using that. Yeah, doing that. So, and also we use that model, the tool will help to predict the important predictor to see if you have multiple inputs, which input is more important. Then we found for carbon dioxide, the second important is roughness. For carbon monoxide, the first important is roughness. So then we show this table. This table I means II, roughness. So you will see on each operating model IDB, a different emission types and fuel consumption. You will see many I's here. For those who are not I, maybe V, which is speed. S, what is S? V. V is VSP, sorry, VSP. S is speed. Some are VSP, some are speed. For those are V or S, I will be a second one, normally a second one. So that means roughness, if you exclude, basically exclude the impact of speed acceleration rate, roughness have good impact on the emissions. So finally, we found that the polynomial model is not good. So I asked the student don't include the polynomial model, but she said, this was my work. So she still listed on the paper of her thesis. She said, this is my bad experience. I tell people this is a bad model, then I got a good model. Good. Yeah. So random tree is much more accurate than a good one. Yeah. And then we have until 3 o'clock.
Yeah.
Oh, okay. Or including discussion or?
Yeah.
Yes, including.
Or including discussion?
Yeah.
Okay. How about I just stop here? Actually, I have another topic on forecasting air pollution. I don't think I have enough time. If you want, I can leave the copy.
Yeah, well, let's go to questions, and
Okay.
then if any of you are interested in this, we'll make sure.
Yeah, if you're interested in that part, this like ozone or similar things and the sunlight, that kind of impact on the forecasting.
To address data mining also?
Data mining, yes,
Yes.
data mining. We even use the frequent patterns.
Okay.
If you took the data mining course, you will see there is a chapter talking about frequent patterns. We use that. And this chart, okay, just utilize that. This is the human hair. The blue ones are PM10. On the blue one, you have the tiny red ones. Those are PM2.5. The tooth very nice.
That's a very nice diet.
Very nice. Yeah. So if you're interested, I can share this one. This was from research from my PhD student. He already graduated. He's in PTI. Also on the mission group.
Well, let's.
Okay.
Thanks for your presentation. My question is actually more about non-exhaust emissions. So I was curious the technology and the app that you mentioned, whether that can be modified to measure some of the non-exhaust emissions.
Yes. The pens, the equipment we have can be used to measure the non-mobile source emissions. Yes. Yes. As long as you have something flow in and they get out, they have the pump to pump out the gas. It will tell you the emissions you have. It's not necessarily the mobile source emission. People have used that one to test a lot of vessel or equipment, or even before the World Trade Center was tear down. They even tested the emission from the World Trade Center. I think the
World Trade
Center in Europe.
The AC server.
Yeah, AC system, yes, something like that.
How about like wildfires and things like that?
Window cannot take Wi-Fi, but it should be like air. Yes.
So to clarify, what you measure includes both the exhaust and the non-exhaust emissions?
Yeah, actually the equipment, it does not know whether it exhaust or not exhaust.
Okay.
Yeah, even the ambient emissions, if you put here the map, it can tell you the emissions in the map. If you have a match, you fire a match, put there, it can show that the PM will go up immediately and carbon dioxide go immediately and the oxygen will drop.
Thank you.
It provides data second by second. Every second it produces a group of data. And to enhance the safety of the test, it has two groups of sensors. It tests simultaneously. And also in order to impact exclude the impact of the emissions from your previous test, it has a zeroing process. Every 15 minutes, they shut down one of the batches of the sensors to let the fresh air in, so that you will not the exhaust gas in the previous second for this cycle will not stay there. It will flow out.
I'm curious about I've never used PEMS before. I'm just curious though how like available the results and data are for PEMS to the general public. And how do I say, like, we don't need the actual PEMS system. We don't need it to go test that on a vehicle. It's all available online.
Actually, we are the customer of PEMS. When we purchase the PEMS, we request about the test result. They are certified by EPA. So we just trust the EPA's result. They provide the chart that they presented to EPA. EPA recognized that. So we think that it's reliable.
So that's the testing of PEMS. But then are you talking about like actual data
like
that's been collected?
Yes, am I an individual able to access PEMS data for my own personal research?
Yeah, you need to talk to the person who connect the data.
So maybe I should speak with you and your team.
Yeah, my team and there are other groups, as I say,
Yes.
Virginia Tech and North Carolina State University.
But not UC Davis ITS? No.
How about Riverside?
Riverside, yes.
Yeah.
Riverside, they have annual PEMS conference. From that conference, you will see almost everybody who does PEMS, they come together. It's now renamed to all the name.
It'd be nice, like, if our Air Resources Board put together all the PEMS data that's been collected.
Yes.
There's something like that?
Yes.
Oh, okay.
It's better. Yeah, we can put together at least within our NCST.
Yeah.
Or our partners. Yeah, please.
Thank you for your presentation. You mentioned environmental justice practices as part of the analysis of impacts. I was wondering if there is a consensus of what those practices are.
Normally,
How do you measure?
frankly speaking, I don't touch environmental justice too much. Yeah, but I know there are lots of people I think social expert in that area. Maybe.
I would not say that.
I have students who are working in DOTs, TxDOT and other state DOTs. They are dealing with the environmental justice issues, they told me. But personally, I don't do that.
Follow-up, if I may. It was very interesting to hear the response to the male and female voices
Yes.
on traffic signaling.
Yeah.
Is there any either further research to do? Any bias control?
Yeah, I see a lot of
Further
research
research
to do in the future.
Policy suggestions?
But there are a lot of research. We just done a couple these kind of studies. But actually, even within the lab, within the simulator, we have a lot of similar tests to do. And you need to do the road test, I believe, before it's formally used.
So when you're testing new traffic control devices or messages, you use the simulator.
We use the simulator.
And then, kind of test it there, and then it's gotta be tested in the real world.
Yes, yeah.
But yeah, lots of fun experimental
A lot
things you
of,
could do.
a lot of things to do. Because in different areas, you may have different message.
Like a very broad question. So like current plans are aiming to, forbidden the sale of gasoline and diesel vehicles. And we are turning more towards electric and hydrogen vehicles. So do you have any plan for the future? Because when we have majority of electric and hydrogen vehicles, these kind of pens are not gonna be very
Yes,
useful.
correct.
So,
Hence, with more and more electric vehicles using, hence will not be directly used, but the logic, the methodologies that we are talking about, some of them are still workable. For example, the operating mode ID, it does not matter what types of fuel you have. And the VSP, specific power, people, I already know people, some people, they are doing this kind of things. And I'm interested in that. With the NCST support, I will do more about borrow this kind of things. But what I did for the modeling, I will borrow that one to EV next. But focus on the fuel consumption, energy consumption.
Yeah, okay, so in other words, you're looking at how people drive and what that means for
Yes.
energy
Energy
consumption
consumption,
rather
yeah.
than emissions.
Yes.
Yeah.
Just like, I think similar table, but on right hand side, you will see FC, right? That's the fuel consumption, the last column is fuel consumption. But I will change to energy consumption. Do a lot of things on the different traffic control situations or roadway pavement, different policy, then to see their impacts on energy consumption. And eco driving.
And for eco driving, I don't think we need to wait for the autonomous vehicles. In my recent trip in the summer to China, they have this phone app. Basically will tell you when the green lights will turn,
Yeah.
how long the red light will be, and it's fairly accurate. So I look at a couple intersections and it's up to within 2 seconds.
So we can use those app for the test, for the overall test.
Yeah.
In simulator, it's easy. Because simulator, we can design that. For the real road test, we can use the phone app.
And so in here, it will be a little bit more challenging to come up with a more accurate estimate because the traffic lights, a lot of them are not fixed time. That means they respond to traffic, they change
Yes.
very frequently.
So you
While
don't know.
in some of the Chinese cities, they
have
use fixed time, so they can learn the traffic
Yeah.
patterns by
Beforehand.
observing enough time.
Yes.
Well, we are out of
So
time.
we have just like one more question.
Okay,
So one more question?
Yeah.
So regarding road design, I've seen statements that a design that is intended to keep motor vehicle speeds at 25 miles per hour or above to minimize emissions. With the ongoing shift to more electric vehicles, will keeping speeds up to minimize emissions be outdated? Does keeping speeds higher discourage walking, bicycling, and transit, thus increasing emissions?
And it is still for the electric vehicle.
Yeah.
For electric vehicle, yes. Actually, this classification on the screen it just gives you an idea. For electric vehicle, we may not strictly stick on that one, especially for the definition of lower speed, middle speed, and high speed, and also for VSP. We will identify the best range. Actually, even for the gasoline vehicle, different people they already have different classifications of the operating mode ID. But this is recommended by the EPA using their rules. But some people they use different one. It's okay. It's okay, and the EPA also recognize that there are many ways. For electric vehicle, I believe it's different. So that's also my research next step. Yeah, I want to see what is the base classification of the operating mode range, speed range.
all right, better let people go.
Oh.